Okay, number 16, we're given a word application for these quadratics. A rock is thrown upward with a velocity of 16 meters per second from the top of a 49-meter high cliff. If it misses the cliff on the way down, when will the rock be 6 meters from the ground? I'm going to round our answer to 2 decimal places. In order to solve this, you need a formula, and right at the end it's giving you the gravity formula because the gravity is going to be pulling this down. So we're going to look up the gravity formula, and it's giving me the gravity formula here. H would stand for height, is equal to negative 1/2 g, which is gravity, and then times t, which t is usually time in seconds, plus this v naught is what it's called. This v with a little zero below it is called v naught. That is the initial velocity. That's the starting point. You start at 0, and then the time, and then of course h naught is the initial height, so where the height that it starts. We are given meters per second. Okay, so you have 2 iterations of gravity. You have 32 feet per second squared, and then you have 9.8 meters per second squared. So we want to use the 9.8 because we are given in terms of meters, and we want our units to match up. Okay, that being the case, I'm going to write down the formula for number 16. H equals negative 1/2 g times t squared, and then plus v naught, our initial velocity, times t, and then plus h naught. The scenario we have is we have somebody on the cliff, and this cliff is 49 meters. Okay, so the distance from top to bottom is 49 meters. And then somebody is throwing a rock. Look at my little drawing. Somebody throwing a rock. So he threw it, and it went up. And then it's coming down, and we want to know when it is from here. 6 meters. So the height, we want to know when the height is 6 meters. We have initial height of 49, which is going to go there. And this is thrown up with the initial velocity of 16 meters per second. So we're going to plug all that in. I want to know when 6, the height, is the height. We have negative 1/2, and then the gravity we're going to use is 9.8. So 1/2, and then times 9.8 for gravity. T squared is our variable, and then plus our initial velocity, which we were told was 16, and then t, and then our original height. He started at a cliff that was 49 feet, so 49 meters, 49. So this is the magic that we need here. You can see it's quadratic, the t squared, t, and then no term. So we're going to set this equal to 0, and then we're either going to factor or use quadratic formula. And I'm thinking we're going to use quadratic formula. Probably going to be the easiest and the most sure way to get the answer. So I'm going to start simplifying. I'm going to subtract 6. I'm going to multiply this together and simplify everything. So if I subtract 6 from both sides, it's going to leave one side with 0 equals. Now half of 9.8 is going to give us a negative 4.9. T squared plus 16t, and then you subtract 6, and that will give us 43. Okay, so let's just double check everything just to be on the safe side. Want to grab that calculator. And then let's shrink it a little bit. Alright, let's clear just to make sure negative. And see what I like about this calculator, it can make that fraction. So I'm going to do negative, and then I'm going to do alpha, y equal, and then enter. It will make that fraction for me. So I'm going to do 1 over 2, and then times 9.8. Alright, and we get negative 4.9. So just to double check, always good to check yourself. Okay, so here's the formula we have now. So we're going to do quadratic formula, which is negative b plus or minus square root of b squared minus 4 times a times c, all of this divided by 2a. Okay, so since t is our variable, we'll actually be saying t is equal to, normally we say x. Alright, so I'm going to plug everything in. Negative b. So we have a negative, but b is 16. So it's going to be 16 plus or minus the square root of b squared. So it's going to be 16 squared minus 4 times a, which is a negative 4.9, times c, which is 43. And then all of this is divided by 2 times negative 4.9. Alright, so I'm going to let the calculator plug into all of this, and I'm going to simplify it at once. So I'm going to plug all of this that's under the square root into the calculator. Double this when I multiply times 2, it's the same thing as what we started with when we took half of it. So 9.8 is going to go back to what we originally started with. So some of this we know, but let's let the calculator do the heavy lifting at this point. Alright, so I'm not going to put the square root in, I'm just going to put everything that's under the square root. So do parentheses 16 squared minus 4 parentheses. Difference on the calculator, you cannot use minus interchangeably with the negative. So the minus is on the right side, the negative is below. You got to make sure you use negative when you need a negative number. Otherwise it will say error. And then times 43. Okay, so all of this will give us 1098.8. So we have negative 16 plus or minus the square root of 1098.8, all divided by negative 9.8. Okay, so at this point, we have two possible solutions. We have negative 16 plus this amount divided by this, and then negative 16 minus this amount divided by this. So I'm going to get both answers and round to 2 decimal places. So again, I'm going to use that neat function, alpha, y equal, enter, and then I'm going to type, you can't see the negative, because the calculator's in the way. I'm going to type negative 16, and then I'm going to do one of them, I'm going to do the plus first. I'm going to plus, and then second, the x squared button to get access to the square root. 1098.8, and then arrow over, get out of there, arrow down. We're going to divide by negative 9.8. Alright, to 2 decimal places, this is negative 1.75. However, it doesn't make sense for time to be negative. So this is saying it's going to be 6 meters off the ground. If we go back in time to 1.75 seconds, which doesn't make sense for a real world scenario. Round to 2 decimal places. So this one is not going to work. We're not going to use that one. So now I'm going to do negative 16 minus and figure out what we get there. So again, what I like about this calculator, I don't have to type all this in again. I can do second and then enter, and it will bring everything back up. And the only thing I'm going to be changing is the minus sign. So I'm going to arrow back through this problem, and when I get to the plus symbol, I'm going to type over it and replace it with the minus. So it's the same thing. Hit enter, and this time we get 5.01, rounded to 2 decimal places would be 5.02. So we get t equals 5.02 seconds. So this is when the ball is going to be 6 meters from the ground.